Okay, so the second half of the unit, we move out of histograms and with like the 7-leaf plot. Like those are good ways to look at data. We now start to look more at the summary statistics, the things the calculator can spit out at us, right? The first thing they kind of do is we look at the centers, which are mean, median, and mode. And then we talk about the spread of data. And there's 3 different spreads that you can talk about. You can talk about the range. And of course, the range is important, but sometimes those numbers on the end do not represent what's in the middle, right? So then there's 2 other spreads that we talk about. One of them is the interquartile range, which is associated with box plots, that box. And then the other one is standard deviation, which is where we go next. And the reason is because a single number is great, but we need more information to describe a full set of data. So today, though, is those single numbers, the measures of center. If you go to page 20 in your note packet, you're going to find the lovely, let's follow along with our video with Party Sabetti. We love that girl. And we like closed captions. We like full screen. All right, Party Sabetti, here we go.
Hello, I'm Party Sabetti, and this is Against All Odds, where we make statistics count. One number most people pay a lot of attention to is the one on their paycheck. Today's workforce is pretty evenly split between men and women, but are salaries as evenly distributed? These histograms show the weekly wages for Americans, separated by gender. Both histograms are skewed to the right, with most people making moderate salaries, while a few make much more. These pictures are helpful in comparing typical wages for men and women, but adding a few numbers could help us understand the situation even better. For comparison's sake, it would help to numerically describe the centers of these distributions. A statistic called the median splits the distribution in half. Half the values lie above it, and half lie below. The median weekly salary for men in 2011 was $865. Remember, this means that half of all men made more than $865, and half earned less. The median wage for women was only $692, just 80% of what men make. Simply using the median, we've identified a real disparity in wages, but it's much harder to figure out why it exists. Some of the difference can be accounted for by differences in education, age, and years in the workforce. Another reason for the earnings gap is that women tend to be concentrated in lower-paying jobs. But that begs the question, are these jobs worth less in some sense? Or are these jobs lower paid because they're primarily held by women? This is the central issue in the debate over comparable worth. The idea that men and women should be paid equally, not only for the same job, but for different jobs of equal worth. Back in 1988, the city of Colorado Springs was at the forefront of this debate. As part of its normal operation, the city government evaluated all municipal jobs with criteria like working conditions, necessary skills, and accountability required. Each job got a numerical rank. It turned out that many clerical jobs, which are mostly filled by women, scored the same number of points as operation and maintenance jobs, which are mostly filled by men. Guess where we're going with this? The median wage for the men's jobs was always higher than the corresponding median wage for the women. And remember, these jobs were judged to be exactly equal in requirements and responsibility. A group of city clerical workers used this evidence to pressure the city for a more equitable pay structure.
Once we had the statistics, then we could actually prove that the clerical employees were being underpaid.
The hardest part was trying to convince the city council and the administration that this was something that was fair, that needed to be done.
The numbers were hard to argue with, and the clerical workers won. The city agreed to equalize the median salaries for jobs of comparable worth, and the plan had an unanticipated benefit. The relatively high turnover rate for jobs held by women decreased.
Because you know that someone appreciates what you do and rewards you accordingly, you do your absolute best for them and you go the extra mile.
you pay fairly, you pay appropriately, no matter what the gender, and you'll find that you have high productivity, high morale, low turnover, and we have fewer employees per 1,000 people served than most cities. So I think it was a good business decision, in addition to the fact that it was just basically fair.
Colorado Springs relied on the median statistic to identify the inequality in men's and women's salaries. Let's take a look at how to calculate this measure of center. Here are the weekly salaries from a hypothetical small company that has 19 employees. If we place them in order from lowest to highest, you can see that paychecks range quite a bit, from $290 for the entry-level receptionist up to $2,000 for the president. So what's the typical wage? Here's how to find the median of this distribution. Count up how many observations you have. In this case, it's 19, so that's our N. Add 1, and then divide it all by 2. This formula tells you where in the lineup the median falls. Remember, it doesn't tell you the actual value of the median, just its location. Count up 10 spots, and there's our median, $500. So 9 salaries at the company are lower than that, and 9 are higher. Since we had an odd number of paychecks, it's easy to count up 10 places to the median. But what if we had an even number to deal with, say 20 salaries? The formula would tell us to count up to 10.5 spaces. That puts us right in between the two middle values. So the median is actually halfway between those two salaries at $525. You probably already know another way to find the center of a distribution, taking the average. Statisticians call this number the mean. It's calculated by adding up all the values and dividing by the number of observations. Back to our original company. To compute the mean weekly wage, or X-bar as it's called in statistics, add up all the paychecks and divide by the number of employees. So the mean wage in this case is $715. That's definitely higher than the $500 median we find for the same numbers. You can think of the mean as the balancing point of all the values. That's easier to see if we make a histogram of the wages. The mean is the value of the pivot point that balances all the observations. The mean is influenced much more by that one high salary going to the president of the company. The median, on the other hand, is what statisticians call resistant. That makes sense. The median doesn't depend on what the values are out there at the extremes of our distribution. If the president doubled his salary while everyone else stayed at the same wage, the mean would bump up to $821, but our median would hold steady at $500. The middle number is the middle number, no matter what the fat cat at the top pays himself. The shape of a distribution can give you some hints about the relationship of the mean and the median. For a pretty symmetric distribution like this one, showing heights of a bunch of 4-year-olds, the mean and the median are roughly the same, less than 1/4 centimeter apart. If a distribution is skewed to the right, like the scores on one brutally tough exam when lots of students struggled, the mean is larger than the median. Likewise, if the distribution is skewed to the left, like the scores on one easy exam when everyone studied up and did well, the mean is smaller than the median. The mean is pulled toward the tail. Remember, it's influenced by the extremes. This is one case where I'm sure my students would prefer to get a typical score rather than the average one. For Against All Odds, I'm Pardis Sabeti. See you next time.
So that stuff at the end falls into multiple choice questions quite a bit because they want to see if you understand mean and median and what they can do versus just being able to calculate things. So it's that critical thinking piece. So when we're looking at wages, even both the men and the women, they were both skewed right. So when we talk about being skewed, which is here in question 2, skewed to the right, it's that whole idea of the tail being pulled to the right. That's not the word tail. Ooh, undo. And the thing with having things that are skewed, then your mean and your median are going to be different. When we have stuff that's symmetric, then they tend to be very close to one another. Then the next thing to say is when, and that's what what questions 4 and 5 were asking, is when you put a few very large incomes up at the top, the mean is going to be affected by those extreme values. And so if we put a lot of extreme values up at the top, the mean will be greater than the median. And you know a good math teacher likes questions that makes words and math symbols go together, man. We dream of these things. Try my best stuff. Okay, then the deal is if we put those large things in, they do not affect the median. So the median is unaffected by extreme values. The median is resistant to those large values or those extreme values. The extreme values could be on the opposite end. And another word that we use for them is resistant to the outliers. And remember, we saw an outlier with Barry Bonds when he was on steroids. He had that one season that was up at like 73 home runs, right? So that was not representative of his actual median, which was down, I think, in the middle 30s. All right, are we ready to turn the page? Beep. There we go. All right, so measures of central tendency. So once again, there are 3 of them that are typical measures, and it's just a single number that represents the data. And that's the thing. That's like a great thing, but it's also a dangerous thing, right? Like my average, my GPA could be 80, but that doesn't tell me that PE is 100 and earth science is 60, right? So the fact is just that single number in the middle doesn't necessarily tell the whole picture, but it's still really helpful to have that. All right, so the thing with mean is that there, of course, and this is true for all the things, we have things for populations and things for samples. Your calculator does it the exact same way. So this symbol right here, and I'm just going to make it a little bit larger. It's like a U, but with a funny tail in the front. It is the Greek letter mu. Okay, and when we go to study inferential statistics, that becomes important because we can't always work with a whole population, but we want to try to figure out what the population statistic could be or that parameter could be. So you say it mu like meow, but mu or the morning dew. All right, but it is the same calculation as a sample mean, and then for this symbol, we sometimes call it X bar. And this is the one that spits out of your calculator. And of course, it's the sum of all the values divided by the number of values that you have. Our mean is our average. And if you know these things, you don't have to write them down. I'm just kind of throwing them up there. It's our sum divided by the total number of pieces of data. So if you have 30 pieces of data or 50 pieces of data, that's what we divide by. All right, so now median is that value in the middle, physically in the middle of the data. So and I'm putting quotes around the word pieces because if you have an even number of pieces, like 10, then just like you could take your 2 hands and separate them, the middle pieces between the 5th and the 6th piece of data when that data is in order. But the thing that we like about a median is that it puts 50% of data on the lower half, right? And it splits your data and 50% in your upper half. And then the mode is the data value that occurs with the highest frequency. And I think this one is powerful because of the visual of like dot plots and histograms. So it's easy to see the mode because it's the tallest one in the dot plot, right? And it's easy to see the mode, even if that mode might be an interval or a class, we can still see that highest range, and that's where our eye is drawn to that. It isn't always the most representative, so we tend to focus back on the other two when we're talking about that. All right, so I'm going to take a pause and give you my example of one thing that works for these two, comparing them. Recently, I sometimes use, I think it's Vintage and Mill. And it's either Vintage and Mill or it's English going out, right? You guys know what streets I'm talking about? I think it might be on English. And you know, I grew up in Hilton, where Hilton was like the outside suburb and then Greece was the inside suburb. We did not, Hilton still has very limited shopping experiences. So coming to Greece to go shopping twice a year, that's a good thing. There were two separate malls. They weren't joined yet in the middle. The Greece Ridge Mall was two malls. Did you guys know that at one point? Yeah. So at any rate, these were suburbs. So there were a lot of house tracks, and this even right across the street, where all the houses have like similar features and they all kind of look the same. And so a lot of times, and this is how property is done if you know anybody in real estate, we talk about the median value of houses. So you can get a picture pretty easily about what the neighborhood is like. Now, why does this matter? Because it's on English. When you drive down English right now, I don't know who lives in that house, but man, they got the double big gate now, and then they got the side gate for somebody, and it's way back, this big, huge mansion, right? It's got to be worth at least 500. I don't know, somebody live in that one? Am I offending anybody? Anyways, I don't live there. It's like got to be somewhere, I would say $1 million property. Do you know what I mean? The thing is, if we took the average of the houses on that street, that one piece of property would take all the property, like what seems to be a typical property, and skew it up. And then people are like, what does that mean for the value of my own house and the taxes I have to pay? School taxes are based on property, right? And so you only want to pay for your property's taxes, not like the next door neighbor's property taxes, because he's got a mansion, or she. Could be anybody, right? So that's why real estate agents use median price, the price in the middle, so that big mansion on the top, and also that house that's been abandoned, that's on the end and it's in foreclosure, doesn't affect the representation for the neighborhood. Does that make sense? Yeah. So that's an example that I tend to hold on to. There's another one that we'll do in just a second, but let's go ahead and do example number 1. All right, because this is super boring. We're going to go back now to exam scores. We just needed a set of data. All right, so here's an example of 22 exam scores listed below. They have been put in order from smallest to largest so you can see what's going on. So we're going to calculate our 3 measures of center and see which one is most representative. So we have our median, we have our mean, and we have our mode. All right, and we'll do 2 of them by hand, and I'm just going to tell you the answer to the mean because we all know how to use a calculator. We'll do plenty of that work later. All right, so first of all, can you skim and see what the mode or modes might be? Do we have any numbers that are doubles or triples? Okay, so who sees some numbers that are doubled or triple? What do we got? 88. So we got 2 88s. Is there anything else that's repeated? 79. And we don't have anything that's triple. Okay, so that means that we have 2 modes. Somebody at my door? It's okay. Should I stop? Was she grabbing something from the printer? It was just some lady.
This makes sense.
Oh, she's lovely. She doesn't know my schedule at all. She's coming in to help with them. Okay, you guys ready? The kids that can't pass the Algebra 1 exam, right? They need some extra help. So she comes by and she helps me with them. Sometimes. They're a different group of people. They're nice kids though. I mean, everybody's a nice kid. They just sometimes like to sleep. But I know people in this room that like to sleep too. Like, we all have our days. Okay, are we back at this? Sorry, that was really cute. To be so sneaky. Or they tried to be so sneaky. Oh my God, terrible. Shoot. They tried to be so sneaky. All right, so there's two modes. What are they? 79 and 88. All right, who cares? Okay, median. If there are 22 pieces of data, that's an even number, right? What's half of 22? 11. So there's going to be 11 pieces of data on this side and 11 pieces of data on that side. Let's find the middle of the data. So you're going to count over 11 pieces and put a line after the 11th piece. 5, 6, 7, 8, 9, 10, 11. All right, my line's between 82 and 85. Everybody else get that? Okay, so now those numbers are not too far apart, but when numbers become farther apart, it might be hard to just calculate it in your head. So when you have two numbers in the middle, that's when you're going to take the average of those two numbers. So 82 plus 85 divided by 2. We're dividing by 2 because we only have two numbers here. And then that means our median is going to be 83.5. Okay, so there's our median. All right, so then you would use your calculator to find the average, and of course you could do it by hand or you could do it in one variable statistics. I'm just going to write that it's the average. And basically, to find X bar, it would spit out the answer, which is 78.6. And the way that it got that answer is it had a sum. So that's a sigma, uppercase sigma. So the sum of all the numbers was 1,730, and then divided by the number of test scores, and that was 22. Okay. All right. So we have three different centers. We have these two centers, we have this center, and we have this center. All right. Now, if we look at the scores, I don't know, these might be extremes, right? Compared to the rest of it. The mean is, so because the mean is less than the median, there are some low scores that are pulling that down. Okay, I don't know if those we actually consider to be mathematical outliers, but they are definitely pulling it down. Of course, we also do have this max score of 100, right? Okay, we can't go any higher than that. So it's never going to be a perfect, it's most likely never going to be a bell curve if people pass. All right. Kind of boring, huh? Great. Turn the page. Beep. All right. This is another favorite one. Here we go. These weren't that bad. Kind of, you could use either of them. But now let's put an outlier in the room and see what happens. So, is there going to be an outlier? And what does that do? Is there a gap in the data set? All right. So here we go. Ages in the room. Do I have anybody that's 16? We got one 16-year-old. One. How many people are 17? 1, 2, 3, 4, 5. So all 17. Nobody's 18 yet. Okay. So that was 6 of you. Okay. Does anybody want to take a guess? I won't be offended. You could say like I'm 90. I don't care. You want to know how old I am? Anybody know? Don't I look good for 53? All right, so this is kind of like our table of data, right? One person. So this is age. This is frequency. All right. So we could even do it as easily as this. Let's say we got 16, 17, 17, 17, 17. I need 6 of these. 1, 2, 3, 4, 5, 6. 53. All right. We got 8 people in the room. What's our median going to be? 17. Gee, guess what our mode is today? 17. All right, friends, let's figure it out. What's our mean? So we do need to grab a calculator for this one. So your calculation could be 16 times, 16 times 1 plus 17 times 6 plus 53 times 1. That's a way to get your total. You don't have to do the times 1 and times 1. I just need a total. I don't feel like doing it in my head. 171? Can anybody confirm that? 171? Okay. Divided by, we got 8 people in the room. This is the saddest class ever. All right, what do we get? We need a decimal. It should be probably like 19 point something. 20? 20 point what? 21.375. Man, I really. Is that where it ends? 375? Yeah. Okay, no dots. So what happened here? Guess what I am? Am I an outlier? Yeah. So this 53 is an outlier. And what did it do to the mean? It pulled the mean. The mean was affected by the outlier. It affected the average age of the room, right? So then, and if you even think about like, I mean, you could almost like kind of laugh at it. If we did like a dot plot, there would be 1 dot and then there would be, 6 dots. And then here we are, there's 53 way over there. So do we have a massive gap? Yeah. So when we have these gaps in data, that's when the mean doesn't represent what's going on. If you take me out of the calculation, clearly we would have a mean that essentially is probably about 17 or 16.9, right? So a lot of times the outlier will be dropped out of a set of data so we can really look at what the data is, because the outlier is a disaster. It's good to know that it's there, but if we want to have comparative data, we might take that out. So which measure of central tendency best describes the typical set of data? It would be the median, because there is an outlier. Because the extreme outlier teacher in the room. Okay. All right, here we go. This is your chance to shine, kids. Can you do it? During a quality assurance check, so in the plant, the actual coffee contents in ounces of 6 jars of instant coffee were recorded as, here's 1, 2, 3, 4, 5, 6 pieces of data. Find the mean and the median. Okay, that's your first task. The third value, 1, 2, 3. This one right here. That third value was incorrectly recorded and is actually 6.04. Find the mean and the median by switching it out, right? So you're going to switch it out and do it again. And then which measure of central tendency was affected more by that data error? Okay, so you got 4 calculations to do. On your mark, get set, rock and roll. We need mean and median here. Okay. All right, what do you have for me so far?
That's the median is 5.945.
Okay, and that's when you've done the replacement,
Yes.
right? Okay, so mean, median down here. So the mean when it's replaced is 5.945. Did anybody get the original mean?
I lowered it.
Okay, so let's just talk about why we're doing this problem. We want to see what happens when a bad piece of data gets in. What does it do? Which calculation is affected? Which one is not possibly affected at all? Did anybody do the medians?
I'm on that right now.
Okay, I'm glad. What about the rest of the people in the room? Anybody? Bueller. Come on. Doing anything? No? Doing any of it? Yeah. Do you have any answers? No. Nah. Do you see it from back here, dude? 6, 7. Can anybody make an observation about the 4 numbers that I've written up here? Did the mean stay the same? Do I have the wrong mean?
No, they're different.
Okay, wait, I don't know. Bailey, did I get a wrong answer?
I thought the median was 6.02.
Okay, let's check. So 599. Okay, wait, 559, 599, and then there's 6 and there's 602. So with 6 pieces of data, right?
Yeah.
So then it's 3 and 3. So then there was a 6 and a 602. What's in the middle of those two? 6.01. Does that make sense?
Yeah.
Okay. There we go. Feel free to ask, when you get something different. Okay, so what happened? The mean was affected by the data entry error. Okay. That goes back to when we were, this feels like I was telling you, we did the pumpkin patch stuff and I asked people to find average and enter all their data. And some people were just finding the average of their random numbers, not the actual pumpkin numbers. And I got those weird numbers thrown in. I'm like, what's going on with our data? And so I threw out people's data because their data was throwing off what was really going on. That's what happens when you have bad data. It messes up what's really going on. So our mean was affected by the data error because the mean takes it factors in all the pieces of data versus the median, which really only takes care of 2 pieces of data, the 2 in the middle or the 1 in the middle, depending what the scenario is. Okay? All right. Turn the page, people. I can see the enthusiasm. All right. So shapes of data. So we're getting to this place where we're going to fully describe a set of data. Fully describe what's going on with Barry Bonds, etc. So another thing we can talk about besides centers is shapes. So here we go. If you look at this one, right? That's the one, that was the one in the video. These pieces, this data shape is called skewed right, because the tail is to the right. The pieces of data that there's a few of are to the right, okay? If we look at this one, what do you think that one's called? Skewed left. Okay, so when we're skewed to the left or to the right, and let me go ahead and just increase this real quick. There's going to be a difference between your mean and your median. So the visualization that was in the video was actually pretty nice, with the idea that the median is always the piece of data in the center, but the mean is the one that you can balance your data on, right? So if I were to try to balance this, I would need to move my finger farther over here to take care of these things that are farther off to the side. Meanwhile, if I actually look at how many pieces of data are there, and I can count this up. I have 2, 3 is 5, plus 4 is 9, plus 7. I should do this earlier. 7 is 16, 25, 36. We go up to 15 more. Oh my gosh. I'm going to guess that there's 50 pieces of data. So like the 25th piece of data is probably somewhere around here, right? So our median is going to be here, but our mean is going to be lower because it's the balance point. So the mean is going to be less than the median because of the skew. In the opposite situation, here our median is going to be lower. And again, what's happening here? The high age, the high salary is pulling up the mean, and the median is going to be less than the mean. So when we have skewed data, they make connections between the centers and comparing them. Now, up above, we have 2 different shapes. Both of them have the centers kind of all the same. So we go up to the ones at the top. This one right here, and she mentioned this one when she had talked about the lightning. I think it was lightning, how like the graph could be folded in half. That's symmetry, right? So because there is like a line down the middle, this is symmetric. And when things are symmetric, your mean tends to be nearly equal to your median. They're around the same. Now, the last one, or actually the first one, is one that we don't see very often. It's relatively flat, right? So we say that the data is uniform, which means, it's all about the same. So this would work, for example, if I had a 12-sided die. And I'm rolling that die over and over and over again. So long as that die is not fixed or weighted, I should have about equal results for every single side. Okay? See, that makes sense to everybody, the idea of probability? Okay, good. So now down at the bottom, here we go, another application question that would be on a quiz. If you were to look at this, this is sick days used by employees. So we can see that 15 employees use, and it looks like about 12 sick days in that year, okay? You guys have experienced teachers being out, right? That's a frequent situation that you're thrown into. If any of you have jobs, you have probably maybe had to call in sick yourself, right? Or you've experienced when somebody doesn't show up to their shift, and you know the ramifications of that. So when we look at this, are your eyes drawn to these couple people in here at the end? And, you know, it's not our business what's going on, but certainly, what are they doing to the mean and the median? Or what are they doing to those different centers? Because there's gaps, and there's definitely probably 2 outliers. When we look at for the measures of center, we can actually predict their location. So I did pause and look at that highest bar, and that highest bar appears to be where the B is located. So when something occurs the most, it's called the mode. So B is our mode, it's our highest bar. So where is the mean going to be? Is the mean going to be at A, or is the mean going to be at C? I have gaps and outliers. There's a 53-year-old woman in the room. What did I do to the age of the room? our average age went up, right? So which one of those is gonna be the mean, C or A? C. So C is gonna be the mean because the outliers raise / affect the average. And we could technically actually calculate the median by counting up how many pieces of data there are and finding where that middle piece falls. But A is the only thing that's left. It's less than the median. So less than the mean. So A is going to be our median, the piece of data in the middle.